Number one, what is the domain of f of x equals 6 over the square root of 4 minus x squared? Especially with your graphing calculator available, first thing I might do, graph that thing. 6 divided by square root 4 minus x squared. And we get a graph that looks like this. Now, one answer that I actually understand is all reals. Okay, so the people who gave negative infinity to infinity, that's understandable because you probably graphed it, you probably looked at this picture and you thought, well, that looks like a parabola, and I know parabolas actually go to the right and left forever and ever and ever, and they have domains all real, so this must be all real. Well, the problem is, this is dramatically different than a parabola. What is actually happening to these curves on each side? They are approaching two vertical asymptotes. Okay? So unlike a parabola that does go to the left and right forever and ever and ever, this curve does not. The farther to the right you go, the more vertical it gets, and it never actually passes through a certain point. But you can clearly see numbers like 0, 1, 0.5, 1.7, negative 1.3, negative. You can see those numbers. So you should have at least had those numbers in your domain. A lot of people writing like 2 to infinity as the domain. I don't see any numbers larger than 2. Graph doesn't mean they're not there, but I don't see it. But is everybody familiar with how to trace? Use the trace tool in your calculator. Here's the point 0, 3. 0 is in the domain. Every one of these inputs has a nice output. All these x coordinates are in the domain. 1.27, 1.489, 1.7, 1.9. And now all of a sudden you can see 2.1 is not in the domain because it does not output a point at all. In fact, if I keep going to the right, I can go to the right forever and I will never find another point. Right? So clearly something happened at 2. Let's plug 2 in. You can actually type specific numbers to trace 2 directly. Turns out 2 is not in the domain. Right? What about to the left? What if I go to negative 1? Negative 1's in the domain. 1.5, negative 1.9. Up, negative 2.12 is not. Well, negative 5. No. Negative 9. How about negative 2 itself? So based on this graphing investigation with the calculator, it seems like the domain is what? Everything between negative 2 and positive 2. Including the endpoints or not? No. Now, if we go back to the actual rule for the function, that kind of starts to make some sense, because what happens if I plug a number larger than 2 in for x right here? Well, when I square it, I get a number larger than 4. And when you do 4 minus something bigger than it, you get a negative. So any number larger than 2 is bad. It creates imaginary outputs. For the same reason, anything smaller than negative 2 is bad, right? Because if you put a number smaller than negative 2 in, like negative 2.1, when you square it, you get a number bigger than 4, and then you get a negative inside the radical and an imaginary. So only numbers between negative 2 and 2, when you square them, create numbers smaller than 4. Now, why does the number 2 or the number negative 2 work? Go for it. Good. It's not because of the radical, right? You can square root 0, but it's because you're dividing by 0, right? Dividing by 0 is bad. Undefined. Okay? So your domain is negative 2 to 2, but not including the endpoints. Now, a lot of people think that and this are the same. Are those two intervals the same? Now, a lot of people made that mistake. They think, well, if I say all the numbers between negative 2 and 2, but not including them, why don't I just say between negative 1 and 1? Well, you've got to remember, there are infinitely many decimals between 1 and 2 that are in the domain, but you're not including them down here. So, okay? Any questions on number 1? How about number 2? First, we can find the composition function. That is going to be 1 over the square root of x minus 2 minus 1. Okay? And that's it. You leave it like that. The only thing you might do to simplify it is get the radical out of the bottom, right? That little rule that people try to pretend you're not allowed to have a radical in the bottom of a fraction. Did you learn that in Algebra 2? That actually is not really important. You can have a radical in the bottom of a fraction in this class. I don't care. Okay. That only existed a long time ago, and they didn't have calculators, because when you do long division with an infinite decimal from the radical, you got to make sure it's in the top of the fraction, so it's inside the long division symbol. But now calculators, who cares? So if you had chosen to multiply top and bottom by the conjugate of the denominator, of which you absolutely did not have to, and only a handful of people did, then you could potentially have the final answer of radical x minus 2 plus 1 over x minus 3. But that's it. Only those 2 possibilities would have gotten you full credit. Okay? If you got anything different, you made a mistake and you're simplifying. So be careful. Now, what is the domain of this function? Well, it is a composite function. So what is the first function numbers have to work for? G. So we start with the domain of G. Well, if you look at G, you should be able to quickly identify that the domain is 2 to infinity. Any number greater than or equal to 2, because it's a simple radical. You got to have numbers that are positive inside. The number larger than 2, when subtract a 2 from them, you get positive. Then what's the second thing you look for? Are there going to be any conflicts at the connection between G and F? Are there any numbers G of X outputs that F of X does not have in its domain? 1. What happens if is 1 in the domain of F? No, because of the division by 0. Does G of X output the number 1? Yes, it does. What number do you have to plug into G in order to make it output 1? 3. So I don't know if a lot of people identified the number 1 as a problem number, but then thought, well, 1's not in this domain. But 1 isn't the number you exclude from the domain. It's the number that causes the 1 to happen. And that is a 3, because what's 3 minus 2? So 3 has to be excluded from the domain. So I'm going to modify this. I'm going to have all the numbers between 2 and 3, but not including 3. And then in addition to that, all the numbers from 3 to infinity, not including 3. Okay, so those 2 intervals combined together make up your domain. So all the numbers greater than or equal to 2, but not including 3. And you can see that. Any number smaller than 2 creates an imaginary. The number 3 itself creates 0 in the bottom. Any questions on that one? Yeah.
And then you got really questions about how to use it.
Well, I knew, so I originally had all numbers greater than or equal to 2. And then I just had to remove 3. So if you take all the numbers from 2 to infinity, and then you chop it at 3, you're going to have from 2 to 3 and from 3 to infinity. And the parentheses are my way of making sure the number 3 itself is not in there.
But like, how did you determine it?
Well, at first, so we have this composition, right? You got your function G, and then you got your function F. Okay, I determined only numbers greater than or equal to 2 are allowed to go in. But the problem is the number 1 comes out of G. And when it goes into F, causes a division by 0. That's a problem. So I need to ask myself, what input into G causes G to output a 1? So when you look at the rule, what do I need to replace X with to make this output the number 1? And that was a 3, which originally I was allowing to happen, right? So when a 3 went in here, a 1 came out, and 1's not allowed to go in there. So I had to remove 3 from those lists of possible allowed numbers. Does that make sense? Okay. All right, number 3 went pretty well. I was picky. In order to prove, the only way you can prove functions are inverses is by the definition of inverse functions, which is using compositions. So when we compose f compose g, that becomes the square root of x squared minus 2 plus 2. You have to cancel the 2's first. The square root of x squared becomes absolute value x, but because they tell us x is greater than or equal to 0, that does in fact simplify down to f. I needed to see that work. I needed to see you acknowledge that. So you thought it, you just didn't write it down? Remember, these are proofs. You already know it's going to simplify down to x. You need to show me. It's like writing an English paper. You don't just think. Like, you don't just think, oh, hey, everybody dies at the end of Hamlet, but you don't write it. Did I ruin it? Nobody ruined it. But yeah, especially with proofs and stuff like that, whenever you know the answer, it's all about the work. And I did talk about that, right? I emphasized that. So, sometimes I could see it was erased. Usually I'm not. Usually I won't grade that. But some people had like some right answers. I saw it was erased in there, and I gave some points for that. But usually I don't. First quiz, that's being generous. Then you also have to compose in the other direction g of f of x. So that gives you what? X radical x plus 2 squared minus 2. So then that becomes x plus 2 minus 2, which does become x. Technically, each of these have restricted domains. It's not just the function x, it's the function x with a restricted domain. But again, I had told you earlier that week, when proving things are inverses, just show that they get down to x. I don't care if they have a restricted domain or not. Make sense? For number 4, a lot of people got number 4 correct, even though I would really like to see one specific answer. The only answer that's really going to help you next year in calculus is if you call g of x 4 minus x squared and f of x 1 over radical x. That was the ideal one. Or even better yet, call that x to the negative 1/2. That would have been even better. Because that way it's powers. Nothing but x to a power, x to a power, x to a power. Right? You got 4, which is technically 4 times x to the 0, minus 1 times x to the second, x to the negative 1/2. That's going to be the most useful in calculus. But if you wrote anything that was correct, I gave you credit. Cool? Number 5 was the bonus, and whenever I offer a bonus problem, you better make it perfect to get that one measly bonus point. Not many people got it. First of all, this is a parabola that has been shifted to the right too, fails the horizontal line test miserably, so therefore it is not 1-to-1. It is many to 1. But if I chop it right through its axis of symmetry, which is at 2, and then I pick a side, I could go greater than or equal to 2. I could go less than or equal to 2. Either half will now be 1-to-1. Which half should we do? And do the greater than? Sounds good. So if we restrict the domain to the only numbers greater than or equal to 2, it will now be 1-to-1 and will have an inverse function. So now we need to find it. So we're going to have x equals y minus 2 squared. We square root both sides. Anytime you square root both sides of an equation, you do get a plus or minus. And then if we add a 2, a lot of people for some reason still wrote minus 2. It is now going to be plus 2, yeah? You're adding it to the other side. So I guess I did 2 things in one, right? I added a 2 to the other side, and then I also flipped the equation about the equal sign. Reflexive property or something. But this is a problem. That is not a function. For each input, that function outputs how many things? 2, right? If I plug 9 into this, 39 is 3, this function will output 5 and negative 1. Not a function. So clearly they're not inverses. So that's where I have to use this information. If the domain of my original is x greater than or equal to 2, that tells me that the range of my inverse will be only y's greater than or equal to 2. So for that one example where I plugged 9 in and it outputted 5 and negative 1, to be the inverse of this guy, it should have only outputted which of those? The 5. Negative 1 is not larger than 2, that should not happen, right? So in order to make sure all of the outputs are always greater than or equal to 2, what do? I cross out the negative. Because any negative number plus 2 will be smaller than 2. Any positive number plus 2 will be greater than 2. So really, your inverse function is the square root of x plus 2. Some people also mistakenly stated that the domain of this function is x is greater than or equal to 2. That is not the case. The domain of the inverse is actually x is greater than or equal to 0, which you don't even have to write because it's implied by the radical. Okay? So to get full credit, I needed to see the acknowledgement of the plus or minus, and then some sort of very basic, as you can see I did, very basic explanation for why I saw you cross it out or erase it or whatever. Preferably cross it out, not erase. And finally, my favorite problem on the whole quiz, definitely a problem I thought people would do better with. I thought the problem I had made up the day before from the homework was pretty good. But we'll check it out. We'll get the hang of it. Okay. Here's the idea. We have f of g of x equals 3. So in this composite function, the two functions that create this composite are g and f. Which one of those twos will actually, which one of them will be the actual function that outputs the 3 at the very end of this? It'll be f. So that's the first thing I want to know. When does f of x, or maybe I don't even call it f of x, when does f output 3? What number has to go into f to make it output a 3? And we use the picture to do that. Outputs are what? X coordinates or Y coordinates? X. There's no Y. I don't know why I said X. Did somebody else say X? I'll blame them. Okay, so here's your Y coordinates 3. So where does F do that? Well, it does it here, and it does it here. So what is one of the inputs that causes F to output 3? 0. What is another output that causes F to output 3? Another input, 3. So when does F output 3? When it has 0 as an input, or when it has 3 as an input? Well, what is really determining what number gets inputted into F? G. So next I ask myself, when does G output 0? Or also, when does G output 3? So let's start with 0. So I go up here, here's an output of 0. So we have this point here. What's the input? So there's one solution. Here's another output of 0. What's the input? 4. So there's two solutions. Next, when does G output 3? Well, here's an output of 3. Here's one of them. What is that input? 1. And here's another one. What is that input? 2. So this problem had exactly 4 solutions. 1, 2, -1, and 4. If you were to plug any of those 4 numbers into the composite, F composed G, the composite will output 3. If you were to look at the composite in detail, plugging these two numbers in cause G to output 0, so then when that 0 goes into F, F outputs 3. Plugging either 1 or 2 into G makes it output 3. When the 3 immediately goes into F, it makes F output 3. Does that make sense? It's a good problem, isn't it? It really makes you think. Good stuff. No questions about the quiz? Everybody agree it was a fun quiz? Good.